Namaste. I, J.V.N. Smritika Chatwal, Assistant Professor in Jyoti Vidyapeeth, Women's University, Jaipur, Faculty of Pharmaceutical Sciences, is here to deliver the lecture on Pharmaceutical Quality Assurance, which is under B.pharm 6th semester. And the topic is Equipment and Raw Materials, in which equipment selection, purchase, specification, maintenance, purchase, specification and maintenance of stores for raw material are going to be studied. This is the continuation of previous lectures in which we considered equipment selection. Now we are going to study maintenance of stores for raw material. The handling and storage of raw material should be in such a way that degradation, adulteration, and cross-contamination can be prevented. So these three can be prevented in the handling and storage of raw material. Storage and specification. In this topic, sufficient capacity, clean, dry, and maintain with acceptable temperature limit, separate significance, and sampling area. There should be storage condition for every area in manufacturing unit. The room temperature should be maintained in 30 degrees centigrade and RH should also be maintained according to AC storage and different without AC storage. Without AC storage, it should be 60% and RH is relative humidity. With AC storage, the storage RH is 25 plus minus 2 degrees centigrade and 45 to 55%. Okay. Now, in labeling of material in storage area, name of product, batch number given by supplier, expiry date, checklist before storage, checklist during storage, and released by per QC unit only. These all are labeled for materials that are stored in area. Detailed written procedures should be established for the receipt, identification, quarantine, storage, handling, sampling, testing, and approval or rejection of materials came under purchase specification for raw material. In purchase specification, detail guidelines defining the operational, physical, and low chemical properties as well as the quality and quantity of a specific item are needed. Mode of purchasing in this by inspection, by sample, by description of brand, and by grading, purchasing can be made. Now, what are the steps in purchasing? First one is purchase application. The second one is after purchase application, the selection of supplies are done. After selection of supplies, inventing quotation is there. After inviting quotation, placing the order is done. After placing the order, if you place the order, after that, receiving the material is the next step. After receiving the material, checking the invoice or bills, it should be done. After checking the invoice or bills, recording of bills in book should be done. After this step, releasing the payment to the supplier is done. And this is the last step. Okay. After that, we should going to discuss purchasing staff should have specific and intense knowledge of products and suppliers. Pharmacists or chemists having knowledge and experience of quality requirement of various material. Quality department, purchase department can be head of purchase department. So there is another opportunity for pharmacists to be purchase department head. So anyone can go in this area. Okay. Now we are going to learn about the next topic, which is in the unit third, that is quality control. Quality control is we are going to start, and in this GMP, quality control deals with sampling, specification, testing, organization, documentation, and release procedure, which ensure that the necessary and relevant tests are conducted. Quality control test for containers. In this, we are going to study the tests which are done to maintain the quality of containers. A container used in the packaging of pharmacopoeial article contains a drug, substance, or drug product with which it is or may be indirectly contact. Selection of container should be done with care and according to the nature of the article. Design, assign of a container or design of a container should be such that the contents can be removed suitably for the intended use of the article it contains. Some commonly used containers are airtight containers that are mainly used because many drug or drug products are susceptible to environmental conditions such as temperature, pH. So the airtight containers are very suitable for these type of drug or drug products. Second is hermetically sealed containers, which are sealed by heat. The third one is light resistant container in which light can't be absorbed or passed through it. The fourth one is multi-dose containers in which other than one dose are contained. And the fifth one is sealed containers in which sealing can be done by any process. And the seventh one is tightly closed container in which the container is well tight closed. And the last one is well closed containers where there is no space for air to be entered. Now, the first one is glass container. Glass is economical, chemically inert, impermeable, strong, rigid, has FDA clearance, and possesses superior protective qualities. Thus, it is used for packaging pharmaceutical. Glass containers are available in various sizes and shapes. There are four types of glass containers, which we studied in class 12. That are, the first one is borosilicate glass, the second one is treated soda lime glass, the third one is soda lime glass, and the fourth one is general purpose soda lime glass. Glass containers such as ampules, vials, or bottles are used to store parenteral preparations. Now, what are the evaluation parameters for glass containers? The first one is crushed glass test, in which the glass is crushed and tested. The second one is whole container stress, in which glass is not crushed and the whole container is used for the test. The third one is chemical resistant test, in which chemical resistance is done. After that, powdered glass test, in which the powder of the glass is prepared and tested. After that, water attack test, in which we are knowing if the glass is leakage or not. And after that, it is thermal shock test, in which we study the test in which we study the glass is shock, the glass is shock, shock bearable or not. After that, there is annealing test. After annealing test, there is vertical load test. After that, it is autoclaving, which is done in 121 degrees centigrade for 60 minutes. Okay. The plastic containers. After glass container, the second category is plastic containers. The plastic container used as a material for container is composed of thermoplastic polymers. If you want to know about the glass test, I am going to differ. So I'm going to discuss about the glass container test in detail. Glass containers may be colorless or colored. Natural glass is a borosilicate glass containing significant amount of boric acid, aluminum oxide, alkali and or alkaline earth oxides. It has a high hydraulic resistance and a high thermal shock resistance. Soda lime silica glass is a silica glass containing alkali metal oxides, mainly sodium oxide and alkaline earth oxide, mainly calcium oxide. It has only a moderate hydrolytic resistance. According to their hydrolytic resistance, glass containers are classified as type 1, type 2, type 3, and type 4. These four types of glasses can be important as the point of view of examination. In type 1 glass containers, which are of neutral glass with a high hydraulic resistance, suitable for most preparation, whether or not for parenteral use. In type 2 glass containers, which are usually of soda lime, silica glass with high hydraulic resistance resulting from suitable treatment of the surface. They are suitable for most acidic and neutral aqueous preparation, whether or not for parenteral use. The type 3 glass containers, which are usually of soda, lime, silica glass with only moderate hydraulic resistance, they are generally suitable for non-aqueous preparations for parenteral use, for powders for parenteral use except for freeze-dried preparation and for preparation not for parenteral use. Glass containers intended for parenteral preparation may be ampules, vials, or bottles. This question can be arise in MCQ that glass containers which are intended for parenteral preparations are whom? They can be ampules, vials, or bottles. The glass used in the manufacture of such containers complies with one of the requirements for hydraulic resistance that are given as containers of type 2 or type 3 glass should be used once only. Containers for human blood and blood components must not be reused. Glass containers with a hydraulic resistance higher than that recommended for a particular type of preparation may generally also be used. Containers for parenteral preparations are made from uncolored glass, except that colored glass may be used for substances known to be light sensitive. In such cases, the containers should be sufficiently transparent to permit visual inspections of the contents. Glass is common material to be used, either non-sterile or sterile liquid dosage form. It leaches alkali from its surface. Leaching of alkali can be reduced but cannot be zero. So there is a disadvantage of glass. So this can become under the MCQ question that what is the main disadvantage of using glass container? And that is leaching of alkali. Hence, a limit test for alkalinity is to be performed before using for a particular product. Now, the evaluation parameters for glass can be started in our next lecture. Thank you for listening. If you have any queries, please let me know regarding this topic. And please make sure to write down the important questions, and please make sure to write down some important notes about this chapter. So thank you. Thank you for listening. Okay.